Alright, so we're going to take a look at actually sketching some rational functions with horizontal and vertical asymptotes. And I have a little list of items, a checklist, so that it makes it a little more routine. And if you'll do this every single time, then you will have an easier time, I think, of drawing these. So sketch the graph of each rational function. Okay, we're going to do that. First thing we're going to do is we're going to identify and draw the asymptotes. And it's important to actually go ahead and draw them, because when we get down to this step down here, it will dictate which numbers that we're going to use for our input for our x. So let's go ahead and take a look. So we have f of x is equal to x squared minus 4, and what are we going to do? I'm going to first look for my vertical asymptotes. When I look for my vertical asymptotes, remember I make sure that everything is factored above and below. So let me make sure that's factored. There we go. The next thing is I cancel anything above and below. Nothing cancels. And then I take whatever remains and I set it equal to 0. Set this one equal to 0 and this one equal to 0, right? And then I'm going to have, these are my two vertical asymptotes. Now I'm going to go to the horizontal asymptotes. And this is bottom heavy, right? And so my horizontal asymptote is y equals 0. Now I'm going to immediately put those on the graph. There's the vertical asymptote x equals 2. There's the vertical asymptote x is negative 2. And here's the horizontal asymptote y is 0. Alright, so now I'm going to check visually for symmetry. When I look at my original equation, I have a number at the top, so I don't have any variables, and then I have x squared minus 4. If I were to put in a negative x, what would happen? If I put in a negative x, nothing would change. It would be the exact same thing. So here's what I know about this thing. I do know that it is y-axis symmetry. In other words, it's an even function. Okay, so that's very helpful. That means if I know what's happening here, then the same thing happens over here. Okay, so I really I'm now gonna move on to x intercept and y intercept. So here we go. So x intercept and y intercepts, if there are any, right? So x intercept means that it's wherever the function would actually be 0. Well, if I set this function is a fraction, right? These are all going to be fractions. So when would a fraction be 0? A fraction is only 0 when the top of the fraction is 0. Well, is a 2 ever going to be a 0? No. So I don't have any x-intercepts on this graph. Okay, no x-intercepts. All right. Well, that makes sense because there's a horizontal asymptote there. But let me just as a little tidbit, the actual graph can pass through a horizontal asymptote. We'll look at that later, but in this one it's not going to. Alright, so y-intercept, let's take a look at that. That's when I place a 0 in for all of the x spots. So here we go. Let's place a 0 in for all of the x spots into the equation. And I get 2 over negative 4, which is negative a half. So let's put the y-intercept of negative a half onto the graph. So I'm going to put that on, negative a half. The y-intercept means the graph is going to go right through there. And I know that on the left side of that and the right side of it is going to be the same. So the very last thing that I'm going to do is I'm going to go ahead and make myself a little XY table. Okay, and so let's see. I'm going to look at my asymptotes. My asymptotes are at x is 2 and negative 2, so I really would like to know what's going on at 1. What about x is 1? And then I'm going to jump over 2 and go to 3. And then maybe I'll do a 4. Because I don't need to do anything negative, right? Because we know that it has y-axis symmetry, so let's take a look. If I put in a 1 into this function, put in a 1 into the original function, I get 2 over 1 minus 4 is negative 2/3. So I'm going to go over 1 and I'm going to go down 2/3. There's that. If I put in a 3, I'm going to go 2. 3 squared is 9 minus 4. I'm going to have 2/5. And That's positive. I got over 3. Now that makes sense, right? That it's positive because look, now I'm over here. So 2/5 would be about right there. Okay, and then I'm going to go ahead with 4, and then I think I'll be able to tell what's happening here. At 4, I'm going to go 2 over 4 squared is 16 minus 4 is 12, so that's 1/6. So we'll put that on over 4 up a 1/6. Now you notice what happens at over, there's 1, 2, here's 3, and there's 4. That's a 1/6. So what, oops, excuse me. So what's happening, there's my dot down there, way down there. So we know that this is going on. We know that this is going to get closer and closer to there. And I will tell you this, that horizontal asymptotes, as x approaches infinity and negative infinity, will approach the horizontal asymptote. So I know that that's going to approach that asymptote. There's no question. Now, this one is going to go like this. I see that that's the curve that's happening, and I know it's symmetric, so I know the other side has to do the same thing. And now I know this is going to do the same thing as the right side. And there we have our graph. Let's go on to the next one. Okay, and let's go ahead through the steps, hopefully a little more quickly this time. So we're going to, step 1, let's go look back at the steps. Step 1 was identify and draw the asymptotes. So if you haven't watched the video on finding asymptotes, you need to take a look at that previous video. So my vertical asymptotes, I always do that first. Vertical asymptotes are after I've factored everything, x plus 3, and after I've canceled anything that will cancel. Then I take the remaining denominators and set them equal to 0. So here are my vertical asymptotes at 3 and negative 3. So let's get my horizontal asymptotes. At horizontal asymptotes, we go back to the unfactored form, and I look at my leading terms, or the degree, and it's bottom heavy, which means my horizontal asymptote is y equals 0. Let's put those on right now. So there's my y equals 0 asymptote. Here's the 3. And the negative 3. Alright, so next thing on the list is to identify any symmetry. So how about symmetry on this one? If I look at this original equation, function, I see that if I put in a negative x, then what would happen is let's just do it. I put in a negative x and I square everything. The question is, does it turn into the exact same thing? Does it give me the exact same thing? If it's the same thing, we'd have y-axis symmetry. But it doesn't give me the same thing. It gives me basically the opposite. So guess what kind of symmetry we're going to have? We're going to have, it's an odd function, and therefore it's origin symmetry. It's origin symmetry. So here we go. We know a little bit about that. That means that whatever happens here is going to happen down there. Okay, so the symmetry stuff is a good thing to know. You don't have to know the symmetry, but it's helpful. All right, next thing is we're going to go with the x and y intercepts. X-intercepts and the y-intercepts. See what's happening there. So x-intercept, let's take a look there. Looks like it's going to be 0, right? I think that's the only time that fraction would be 0 is when x is 0, so x is 0. And then the y-intercept, looks like that's also going to be 0, because when I put in a 0 for x's, I get a 0 at the top of the fraction, so it's going to still be a 0. So let's go ahead and put that point on. We've got a point at the origin. Now, look at this. This is a point going through a horizontal asymptote. I told you that that is possible. It's never possible for a graph to go through a vertical asymptote, but it is possible for it to pass through a horizontal asymptote. So that's perfectly fine. Doesn't happen very often, but it's fine. So the last thing that we're going to do is we're going to make ourselves a little XY table. And let's take a look. We want to know, this is origin symmetry, right? So if I just know what's going on here, then I'll know what's going on down here, right? Because now you could give yourself all the points you need. You don't even have to use the symmetry information, but I'm going to go ahead and find out what happens at 1 and 2. Then I'm going to skip over to 4 and 5, and then I'm going to be ready to graph the rest. So let's take a look. What I typically do is I go back to the factored form, you know, the x plus 3 x minus 3, as long as nothing canceled, right? The factored form, and I'm going to dump in a 1 into there. So that's going to be a 1 over 4 times negative 2, so that's negative 1/8. Pardon me. So over 1 5/16. Okay, so we see that if there's no symmetry, I'm going to go ahead and take a look at my x and y intercepts. And x-intercept is when the whole thing is equal to 0. The whole function is equal to 0. Well, that means that if the fraction has to have a 0 at the top, because that's the only way a fraction can equal 0. So we make the top set equal to 0 and we solve for x. So that's going to be negative 2/3. Okay, so the x-intercept is negative 2/3. I'm going to put that on. Negative 2/3. There's that. The y-intercept is when we drop in a 0 for the x's. We don't make the y 0, we make the x 0. So that's going to be 2 over 1, which is a 2. So my y-intercept is 2. So let me put a dot at the 2 there. Now, immediately, now, I know exactly what this graph is doing. This is just doing this, getting closer and closer there. It's going to approach as x approaches infinity, it will get closer and closer to that horizontal asymptote. Okay. Now this is going to do the same thing over here. I'm going to make sure that I put the points in the right spot. Let me give myself just a few points. I'm going to give myself a negative 2. Why? Because that'll tell me what goes on right through here. Negative 2, right? And then I'm going to give myself a negative 3. So let's take those two, drop them in. If I drop in a negative 2, it's going to give me a 4. And so I have negative 2, I get a 4, 2, 3, 4, 1, 2, 3, there it is right there. Well, that makes sense because that's exactly opposite of it's kind of like it's the vertical angle opposite of the intersection of my asymptotes. And then if I put in a negative 3, looks like that'll be 7/2. Oops, 7/2. And so negative 3, 7/2 is what? 3.5? Perfect. Okay, so here we go. This is this. Does the kind of the mirror image across that intersection there of the asymptotes. Okie doke. Thanks for watching.